There we go. Sorry about that. Had some microphone problems, but now we can finally begin. What's up, Derek? What's up? What's up? Okay. So, what we're going to continue with today, that's a pretty nice shape, is the soft body. We have a very simple version of a soft body in place. Experimented a little bit yesterday. We're going to improve upon this, but I also want to add it to the procedurally generated blobs. One thing I also want to do, which we're going to look into more, is so currently, so this one has 4 bones and 4 joints, and like these 4 joints, they actually affect, let's see here if we can get, okay. I think it was these, right? Yeah, so these 4 bones, they actually affect the position of the full object. So I also want to experiment a bit with that, because eventually I want it to work the same way the leak works, pretty much. So you have one main bone that controls the position of the entire object, and then you have a number of joints that only their position are dependent on the main bone, but they do not affect the main bone. Put this one up 100. It's gonna fall through the ground, yes. It's kinematic, and where do we have it? Something like this. I don't think these bones, no, these bones just do not affect the position of this one, if I recall correctly. And I think we want something similar when it comes to the blob, because eventually we're gonna like animate it, we're gonna make it move around and stuff like that, and I don't want the soft body physics to affect the actual movement of the blob. But what we're gonna begin with today is we're gonna procedurally generate bones and procedurally skin the model to these bones, and then we're gonna add nodes here that manages it, because basically we're gonna create a simplified version of this UV sphere, and then we're gonna select how many vertices of it we want to spawn bones for, and then we're gonna skin those bones. And I think we already began this yesterday. So here we have a nice blob model, a very nice blob model if you ask me, and you can see that it's pretty high poly, but then we have a few set vertices. I think it's 5 rows and 4 columns, pretty much. And this is where we're gonna spawn bones that are gonna control the soft body physics. So I think we're gonna begin today by, yeah, let's just continue working with this test script here and create some bones. Yeah, actually, let's do this. Let's add a quick to-do here. This one I would say... XPBD. But okay, yeah, I just want to have a quick to-do list. Let's put it split. Okay, so what I want to do now is we're going to take it here. So I wouldn't really say it's a soft body node though, but yeah, you get it. So, okay, what I want to do first is create bones based on simplified mesh. And when we refer to bones in the game engine, they don't have as much functionality as you would see in Blender, for instance. We're just talking about transforms, basically. So, a point in space that has position, rotation, and scale. Scale doesn't really matter, I don't think. So we're pretty much just going to create a set of transforms based on a simplified mesh. So we're just going to take the points of the simplified mesh, and that's it. And then we want to... Okay, this is going to be the hardest part, I think. But fuck, I thought we had... Here we go. We're going to do something like this. So, in mesh to these bones. And then we're gonna have add joints to these bones. Let's start with those 3 tasks. When we have them under control in our test script, we want to implement it a little bit nicer and move it onto our node implementations. Or we want to implement it as nodes, pretty much. So let's see here. We have the mesh, we have the points mesh, and then I would like to be able to get our points. Do we have... we have vertices which are public get, private set. That's perfect. So let's see here. Private void create bones, I think we're gonna call it. And I think we're gonna do it from dynamic meshes actually. Here. Bone mesh. Let's see here. Per vertex, we create a game object bone, new object bone I, position, transform point, vertex position, and parent is this transform. That's great. But then I also want to change the, we're gonna do this bone dot transform dot look at, what do we have here? Look at, I don't want to do a look at target actually. Do we have any other world position, world up? Actually, I'm wondering if we can just do this vertex dot normal. Let's try it. Okay, something like this. MF mesh, MF material, standard. Let's add a nice material here as well. Okay. Point mesh, and we actually want to, yeah, this is exactly how we want to do it. Yeah, let's try this. Let's bring it up a bit and okay, let's see what we get with this implementation here. It has some children, so that's good. How many bones should we have? We should have 4, 8, 12, 13, 14. Okay, beautiful. It might be a little bit too much. I'm wondering if 2, longitude 2 is enough. Probably. Or latitude. I never learned. But let's see here. Bone. Okay, we have this one. I want to see global, local. Okay, beautiful. One thing I'm wondering here. I'm not entirely sure of how I want to do with the right and... I think we're gonna change that as well. Because I want to have some system with the... like, look at this, for instance. So for this bone, we have X upwards and Z to the right. For this point, we have Z upwards and X to the left. That's not good. But the most important part is that the normal or up is inwards, and it's aligned with the normal, so that's good. Yeah, that's good as well. Okay, beautiful. I definitely think this is good points or good bone transforms. Before we continue, let's get the right and Z in a correct place as well. Wonder if we have transform dot rotate towards, maybe, or actually I think we can do this. Transform dot rotation is equal to turnion dot rotate towards from to rotate towards is probably not. Here we go. Look, rotation. Forward, we want forward to be vertex. No. Forward, upwards. Okay, so we want. Let's just do vertex normal for both of these initially. But for this one, I think we want to do the binormal or whatever it's tangent. We will not have tangents and binormals. Normal. Okay. I guess we can create a fake binormal, but I'm wondering if it's important for me that we have some like there's some logic between the different points and the tangents, so we don't get like a total random direction between them. But we'll see. I wonder if we can do, let's see here, math, extension. Do we have something here? Random Gaussian. I only have it in util math. I'm wondering if we are gonna run with something like generate tangent. I'm wondering if we're gonna do something similar to this. Because you don't have something like that in the Unity math. Not mathematics, but math F. Okay. And the idea, positive, inverse, lerp, a random point, random Gaussian. Yes. Yo, what's up, Cynic? And then we can add a nice little method here. I wonder if we had one in triangle. Here we have normal. I find it weird that we don't have bitangent or binormals or tangent here either, but we do have them in edge, don't we? Yeah, we do. Public normal, tangent binormal. I wonder if we should just do, yeah, I think we should do this actually. Normal, public, but instead of this, we're going to use epsilon. And then we should be able to use this one here. Vertex tangent. Tunic in a meeting, just wanted to say hi. Appreciate it. Long time since I was here. Yeah, indeed. This is first time this year, right? Maybe. Yeah, I think so. Or maybe you were here early this year, actually. Hope everything is going great. And no complaints. Oops. Okay, let's see what kind of bones we have. Okay, this one is... Really? Oh, yeah, I forgot to do one thing. We want to do minus normal here. But then I'm wondering how we're flipping the normal. Maybe we should flip the tangent as well. We'll double check what kind of result we get here. It's... So the forward and up we're interested in. Upward should be inwards, like this. And what do we have here? So here we have... I'm wondering if I do want this one to be... Yeah, maybe. We'll see. So, always to the right. That's good. Okay, that's beautiful. And then we have this one. Beautiful. 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 Okay. Okay, this is actually great. But what I want to do is... We're gonna jump to vertex again. We are gonna introduce... We're gonna introduce public vector 3 binormal. And we're gonna add a binormal here. It's gonna be... this, yes. Yo, what's up, Diggy? Good morning, good morning. Oh yeah, I forgot to change the most important part, test. We want to change the tangent here to be binormal instead. Because what I want is, I want my x to be towards the right. And I want my forward to be upwards along the figure. I think this is gonna be, well, this is important. Like, I'm 90% sure this is important. Yeah, because can we get, or is this one gonna be to the left? Okay, what's important is that all of these are the same. So we have forward, downwards. Downwards is also okay. And we want Y inwards. Okay. Because we're gonna play around a lot with this, or we need all of these to be the same when we create our joints later on. Because our joints are gonna have specific setups for let's see here, for the axis and secondary axis. I think it's just going to be way easier for us to set up these configurable joints procedurally if all of these points are the same. But I think this is it for the bones. So we have a pretty good setup for the bones here. That's beautiful. Diggy woke up early, but have to get ready for work soon. Looks like you have made a lot of progress since last time I was here, though. Yeah, we've made some pretty nice progress. I hope you watch my shorts. I try to keep them up to date to what I've done last week nowadays. But yeah, it's moving pretty quickly. I'm hoping that we can get some nice, that I have the time to get the jiggle physics or the soft body to work on the blobs today. But we'll see, Maybe we'll do it early next week in worst case. But okay, now we have our bone positions. So that's the first task, pretty easy. Now we want to skin the mesh of we want to skin this mesh to these bones, right? So I think we're gonna do private list transform bone transforms. Yeah, let's just add them like this. So now we have a list of bone transforms here. And let's take a look at this one. What I worry about in this solution is that we might not have or I'm wondering about okay, you know what? I think we're gonna do this a little bit differently, because what I want to do is I'm gonna work towards a we're gonna be quite costly here with how many bones or how many bones each vertex is affected by, and I'm gonna go with 4. So we're gonna have to calculate. So when we go through a vertex, we want to find the 4 closest points to that vertex. And then we want to calculate like if we have this vertex on the, yeah, then we probably want it to be 1. Yeah, that's true. So we want to find the 4 closest bones. Then we want to calculate a like normalized weight. So each of these bones should have between 0 and 1. If we're on this one, it should have 1. So like this bone should affect this vertex 100%. A little bit less and so on. But so what do we do? Distance, total distance, or like distance from the vertex to the bone divided by total distance of all of them and 1 minus. Is that okay? Cynic, been battling with some stuff at work and now I'm moving away from software into production within the same company. Yeah, that doesn't sound very good if software is something you want to do. Sorry to hear, man. And good luck on the job hunt. Okay, let's see here. Because I don't think this one takes that into account, the current one. Cynic, yeah, kind of sucks, but going with the flow. Yeah, that's the best thing to do, I think. What are we working on? Looks like a raindrop. Yeah, we're working on the Blob creature. And as always, I recommend my latest shorts to get up to date. But it's pretty much like we're procedurally generating blobs of different shapes and different properties. Diggy, hope you have a good day, bro. You too, you too. Thank you for dropping by. Appreciate it. Okay. How would one implement a method that takes a list of transform bones and a mesh and then skin the mesh to these bones with 4 bones per mesh vertex. Unity. I should get that by context. I will see. But yeah, I think we're gonna find the 4 closest bones and we're gonna calculate like total distance and then we're gonna assign them relative weights and something else. I will see. Skin. I don't want to do that just yet, so let's keep it like this. Okay. Build or obtain a mesh instance, compute bind post from each bone transform. For every mesh vertex, choose the 4 closest bone and assign normalized weights. Put bind posts and bone weights on the mesh, assign mesh bones and root bone to a skin mesh render. Yes. Okay, easy peasy. Skin mesh 2, bones 4, host, source mesh, eyelist. Weight sharpness. Okay, so first we set but shouldn't we be able to legacy API? Okay, honestly, what I want the most here is what I care about the most is this one, I think. Man, what's up, yo, yo. Inverse distance weighting. How's the blobs doing? They're doing pretty fine. I think they're all happy that they are soon gonna get some like soft body physics. But I just wonder if I wanna... I think I just want to solve this with some link stuff. I love link. We don't care about speed here, I don't think. So for instance, I'm wondering if... Fuck, do we have... We actually have a dynamic mesh here. No. Okay, we have a mesh. So I'm wondering if we want to do something like this, like vector 3, or maybe we can do... Or... Wait. new bone weight. I'm wondering if we want to do bone weight. I probably want to use bone weight 1 later on. I think that's the new one. But we have vertices count, and then we do yes, but remove these. And I'm wondering if we want to do something like this. Let's see here. Mesh dot vertices dot dot order by transform point. You know what? I think we're just gonna go with no, it's not the vertices. Fuck, I'm tired. Here, let's do for vertex we want to do bone transforms. Do we need to? No, we don't. Bone transforms dot order by, and here we have bt equal 3 dot distance, bt position, and then I think Muklas, what's up? Yes, we are. I'm wondering if, yeah, let's take vertices I dot position. Yeah, and then eventually we want to take or, and then we want to do something for all of them. We want to calculate new class. You're using Claude. Are we using we're just using auto here, so maybe sometimes not. Take 4. Then I want to do auto. What's that? That's not like we have a GitHub Copilot subscription, and then you have the option to choose which model you want to use. We just have it at auto right now, so I guess it uses the one that has the least traffic, which is, or the one that is currently the cheapest to use for them, but that's just me guessing. But let's see, we order them and then we take 4 because that's all we want, and then we want to do some calculations, and I always forget. We need to do something for each element, or transform each element. Select. You know what? I think we're gonna have to... yeah, we're gonna have to summarize... Before we order by, I think we want to do... like, is it select? I think we want to start by calculating the distance and create some tuples. Okay, beautiful. So it is select. Select. We don't care about I, but we do. So select BT, and then we create a BT is the BT, and then we have distance, which is this one, right? Yes. And then we order them by, like, what do I want to call this one? BTD. Distance, and then we take 4. Closest bone transforms is equal to, and we might want to make this into a list. You know what? Okay, so now we have 4 bones, 4 distances. We just want to add the sum of the distances. Let's see here. Do we actually calculate this first? Because if we do, inverse distance weighting. Actually take 4. I think we want to do mathf dot min for and bone transforms dot count. But we want to calculate. I don't think we're gonna have distance here, or maybe we are. Now we're just gonna do inverse distance, so distance plus epsilon. What do we have on epsilon? Bone BT, and here we're gonna do I think we want to do mathf.pow distance plus epsilon, but I think we can use this one, and then weight sharpness we just do 0.5f here. And then we need to calculate this one and then divide it. Float weight, yeah. Total weight, some BT weight. And then we calculate. Yeah, then we can create the weights, can't we not? Let's see. New bone weight. Can we create this one in a cool way? Oh, is 4 actually the maximum? It's a struct. Okay. I would love to. Maybe we can do. If. If closest bone transforms dot count, not count but length dot dot count is equal to 4 else. How would one go about doing this? Do we have any overrides or something like that? Can you actually do bone weights I dot, but can you do this? Yo, what's up, AC Designs? I like the stream layout / setup. Having this to do beside the code is nice for us viewers. Yeah, that was pretty much the idea. But I mean, it helps me too. But okay, I don't really see a nice way to do this if we have less than 4 bones. But I mean, I guess we can do this. that actually the best solution? I'm questioning this. Okay, let's do if it's equal to 1, two, 3, and then we just go with 4. But then I wonder, like, so if it's just 1, then we probably just want to do weights I dot bone index 0 is equal to 1.0f, right? Or is equal to oh no, is equal to, fuck, that's true, we need the index as well. We need the index as well, so select BT. I'm wondering if I want to have a custom struct here to make it a little bit easier. We're going to include this in our graph later on. Maybe it's a good idea. Maybe it is. Bone array bind pose. Bind poses. Local position. Bone weights, recalculate bounds. Okay, I'm actually thinking about doing public. We have dynamic mesh bone setup, I think we're gonna call it. And I want to make it into a we're gonna make it into a class. We're gonna have, yeah, let's just make them public. So we're gonna have a public index. We're gonna have a bind pose, which is gonna be a, do we use the same bind pose? No, one bind pose per bone, right? We're gonna have this, but bone setup is gonna be public transform, public int index, public. We're gonna have a weight definitely, but first we're gonna have a bind pose. Makes me wonder if we have something similar already, but okay. And weight, maybe not weight actually. No, of course not weight. Let me change this one to bone setup. Bones. Bones.add. Question is, let's add one. Public. There we go. Okay. Where do we have our bone? Okay, our game object, bone. You know what? Actually, I think we're gonna make... I'm gonna keep it like this. This is Unity, right? Yes, it is. Yeah, then we have the game object here. Let's change these to... Oops. I think this is what we want to do, right? Fuck, do we need to cache these? I guess I'm confused why you're manually creating and parenting bone objects. Doesn't Unity have ways to handle this stuff already? Like, we're procedurally generating creatures that are gonna have different bone setups. So we need to create the bones and then skin the mesh to these bones manually. Yes, sir. Right now, so what we're generating now is... We're not generating an armature to... Let's see here. Let me just go through real quick what we're currently doing, and hopefully it will be a little bit clearer. Eventually we're gonna generate like real armatures for some creatures, but we're starting simple today. So we have these objects the objects you see here, and these are blobs. They are procedurally generated when we spawn them, given a seed. They have different shapes and colors and stuff like that. And what we're trying to give them right now is like this jiggle physics, or we want to make them be soft bodies, right? So something similar to this soft body we want to add to these blobs. So we are, this is our test object. So we choose a number of points on this test object, and that is where we spawn our bones, and then we want to skin this mesh to these bones at runtime. And then we're also going to make them into joints, and they will have like a soft body. It's a very simple version of a soft body, but it's okay for what we're doing. And I want, like, the bones are going to be placed based on shape, and the number of bones is also going to be like customized in our setup. So we have this graph system as well that controls how our creatures are generated. It's a whole thing, but that's the gist of it. Yo, what's up, Mega Burger? Slowly going insane during my backend coding. Backend coding. Going insane during such a fun task is the word I'm looking for. What's up, Latromi? And meme, cool stuff. Yeah, I think it's pretty cool, and I think like generating creatures using this graph is also pretty cool. But okay, on to this. So now we have a bone setup we can use instead. I think this one is going to be better. Bone game object, the index of it, and the bind pose. Anything else? And then we have bone weights. So bone transforms here, it's gonna be bone setup. We'll see if we can simplify this one a bit. Let's see then. Public load distance 2. Is very interesting. I can't say I know many games that do procedural mesh generation, especially in regards to interactive objects rather than like worlds. Yeah, I guess procedural generation is... it's most commonly used for like environment stuff, I guess. Like Spore is a game that always comes to mind when I work on this game. It's very similar. I haven't played much Spore, but I think they used a lot of procedural generations for the creatures, right? Bone weights are just the amount of influence they have over actual mesh and vertex faces on the mesh itself when moving, right? Yeah, pretty much. So each... let's see so I get this correct. So each vertex has a set of bone weights tied to it. And it pretty much... so each vertex is moved, and they decide how much those specific bones affect the position of that vertex. Mega Burger for a fucking like button over 500 lines and some JS shit, whatever that is. Okay, I get it. There's a lot of stuff going on in the background, right? In the back end compared to the... What the fuck is the opposite of back end? Oh well. Okay, let's see if we can simplify this one now. Select closest bone transform. We want... Let's just call these bones. And distance to vector, we're gonna do it like this. And then we order by distance. And then we select... You know what? I'm wondering if... Yeah, we probably want to take 4 first. But I think we're just gonna... For now, we're just always gonna assume that we have at least 4 bones. So we're just gonna do 4. Let's keep it simple today. And then we want to select this one as well. And what do we want to do? BTD... B, order by B distance. And let's call it BD. Bone distance. And then we take 4. And then we also want to calculate this, but okay, so I guess we want to call this one BW. BT. We just want to call this one B. Okay, this makes a bit more sense. Okay, so now we have the closest bone. Closest bones with weights. Then we want to get total weight. We want to sum this one. And so we're doing this, and then we want to create the weights. So let's just do it like this. Bone weights. I is equal to new bone weight. And let's see if this one has it done. Element at or default. Can't we just do... Am I too optimistic? Or can we just force it element at? Yeah. It's a little bit unsafe currently, but let's do something like this. Front end is the opposite of back end, yes. And I think that's it. Find post bone weights, recalculate bones. Okay, so skin mesh. So when this is done, we have a list of bone weights per vertex. Bind poses. So I think we want to do... We don't want to have a mesh filter here. We want to have a skinned mesh renderer. Skin mesh. Do we? Okay, this is just temporary stuff, so I think we're gonna do... So after all of this, what we do then is we do mesh dot bind poses is equal to bone transforms bones. It's equal to bones dot select b bind pose to array, and then we do mesh bone weights is equal to bone weights. Didn't we have anything else here? Maybe an index. Now we use the index here. Yeah, we do. That's to the... Okay, I think we're gonna send in a skinned mesh renderer here as well. SMR. So then we have the mesh, then we do SMR, shared mesh, SMR bones. We are gonna assume that they are ordered. And then we want a root bone as well. Izzy, I gotta go tonight, but I hope to see you around and live again. Thank you, appreciate it. You too, take care. I can just mention as well that I stream on Mondays and Tuesdays, and like the best way to know when I go live is either by subscribing to me on YouTube or joining my Discord. Appreciate it, appreciate it. I haven't really thought about what to do with the root bone, so I'm thinking of doing... You know what? I think our root bone is actually gonna be... I didn't think about this, but maybe... Yeah, I want to go the other way around here. We want to do... We want to go from the bottom up, so... Bone mesh, where do we have it? Mesh, get mesh. Yeah, this one. I think we want to... Yeah, let's just go... -1 and I is bigger than 0, right? Or actually bigger or equal to 0. Because that way the first bone we create is the one at the bottom of the blob, and then we can probably make that one the root for now. And so that's just gonna be bones. There it is. Okay, is that actually it? I wonder. Hope it is. So instead of a mesh filter and mesh renderer here, I guess we want to add a mesh or skinned mesh renderer. And then we add it, and then we have material is equal to material. And mesh and then we create the bones. Would love to get, we fill it up, maybe that's, yeah, not a very big fan of that, honestly. So let's do what am I missing here? There we go. I want to wait with that. Let's see. Create bones will return a list of bone setups. Okay, bones, and then finally we do skin mesh, SMR, unity mesh, bones. I guess that's it. Hopefully it works on first try. Okay, we have one error. Mesh bone weights is out of bounds. That's not good. I get some more information. 91. Really? Bone weights is vertices count? Ah, point smash. Okay, that explains it. Fucking hell. You know what? I think we're gonna remove this one. And it's not the vertices we want to use here, it's the mesh.vertices. So vector 3 mesh vertices. Yes. Okay, let's try this then. Okay, let's see. No error. That's good. We do have some kind of object here. It has a skinned mesh renderer. It has a root bone, the bottom one. So now my question is, can we move these around and deform it? And the answer is no. Whoa, 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 whoa. Okay. Our first bone actually... Okay. We have something. Holy shit, this is bad. You know what? I might know something that's wrong at least. Let's see. I'm worried about the reverse here. Maybe not. Yes, I think. This will probably help it a bit. Bone. Oops. That's not it. That's not what I want to do. But, oops. I'm wondering here. And the index here. Do it like this. I minus right. That's not correct. But still, we have... Okay, I might also know something else that is wrong. But let's see if we get the correct. Bone 13 at the bottom. That's not what I want. Let's see here. I just want to reverse this one. Bone mesh, vertices count. Yeah, you know what? Bone index. Bone index. Okay, that should be okay now. Bone 0 is at the bottom and bone 13 at the top. Okay, great. We still have... This is extremely weird. But okay. Create bones works. Let's see skin mesh. We send in a skin mesh renderer. Our mesh. And the bones setup, that is. For each... Okay, so for each vertex... we get the 4... Yeah, we get the 4 closest bones. Yeah, what's up, PG King? How is today going? Pretty good so far. I think we ran into our first big error right now, so we'll see if we can handle it. And then we calculate a weight like this. Oh, did I fuck up here? Maybe... No, I don't think so. And we calculate total weight like this. I think weight sharpness should be 1, but I'm not entirely sure. Yo, what's up, Antonino? It's going pretty good. PG King, errors are nice in a way, yeah. In a way they are. And how is today going for you, PG King and Antonino? Like, I wonder why... Now this should be... Maybe is bones is sorted by bone index, right? So first we add 0, 1, 2, 3, yeah. Oh, you know what? Square magnitude, that explains it. Weight, sharpness. I think we don't want to do PD distance 1 divided by... Yep, I think we just want to do this here. But that's true. We might want to return squared distance here to save a lot of time, but we'll see. PG King, well, I'm sick. Just got out of the doctor that made me stop work for the entire week. I don't know the English word for that, actually. More time to code my little game that's becoming not so little. Sounds like you should rest, my man. But I mean, maybe coding a little game that's not so little anymore is rest. Depends on how you see it. Antonino, today we found a problem in the way we were saving file in the company internal cloud and database. Time for work. Hopefully you can fix it. Hopefully you can find a solution. Oh, look at this. Okay. I think we are... It's still so bad. But... Okay, it's still very, very bad. What the fuck? It's almost like... Okay, I probably know what another problem we have. And it's... We have to be careful with world position and... Like world position and stuff like that. Definitely. Where do we have it? PG King, it is very peaceful and with a lot of stops to watch streams and YouTube videos. Okay, that actually sounds pretty relaxing and nice. What's up, bro? Antonino, by the way, the slime simulation is really good. Oh, you mean the soft body we have? Yeah, I love it as well. I'm dying to see the blobs utilizing it as well. I think it's going to be beautiful. Meme, working on your own game after doing game dev for job hits differently. Yeah, I guess it is. That's a sad reality. But okay, I think the problem here is that our vertices are in local space and our transform here is in world space. Bone local position, yes. Host world to local. Yes. So let's see if we can fix that. But to be able to fix that, we're gonna need... We have the bind pose. So I think we're gonna do this. Bone. Let's see. Okay, I want to try and do this. Let's see. We're gonna change the constructor. It's not gonna be bind pose here. Instead, it's going to be transform parent. We're gonna have bind pose here, but private transform parent. And yes, parent. World to local matrix. Let's see, bone game object, so that's game object. And then parent. Let's see if this is correct. Local to world. Yeah, I think this is correct. So we do it like this instead. And then we're gonna have bone set up. I want a public vector 3 local position. And that's not really what we want to do, but I want to do, let's see, game object dot can we just do that? Okay. Host parent dot world to local matrix multiply 0.34. Yeah, let's do it exactly like they do it. And here we have game object dot transform dot position. I think this is how we want to do it. Local position, super important. Bones are created the correct way. But here we have bone position. Oh, actually, distance to vector. Here we do game. Yeah, that's not what we want to do. We want to do local position here. I'm pretty sure. Because our vertices are... It's a little bit unclean, the way we have named it and stuff like that, but hopefully it works. Yo, what's up, Jax? Okay, it already looks pretty shit up here. Wonder why though. Bone 0. But actually, let's do... Is that the basic lit? That's not what I want. Okay, that will work. Have I moved this bone? I wonder if we want to offset these bones later on, make it a little bit nicer. I don't think they should ever have... They shouldn't be totally... tied. Escape from, maybe you should use a lighter and longer fall off for the bones. Hi. I think it should be, so we have 4 bones per vertex, and the closer they are to the bones, the higher the weight they have. You can see that the point exactly at the bone is following it perfectly fine, and you see a little bit less here. I don't know if that's what you mean, but yeah. And then you're always, if you do a bone solution, you're always going to get a result like this, because a vertex can only have 4 bones, I think. Scafer, can Unity display bone weights visually? I don't think so, but I have my own custom script to do that eventually. Maybe we can add it to this one. I'm not... Let's see. Let's see. Yeah, we're gonna get some problems. Let's see if we can change this one to be awake. Start instead. Escaper, I think there's a setting for bone count per vertex or something like that. Yeah, there should be. I don't think we want to go higher than 4, though. But we'll see. Okay, no errors, so let's see if we can visualize. Okay, that's not good. Yeah, I don't know. We're not gonna visualize it now. That's not... But maybe we should do it later on. But... what I'm wondering is... I know that you can have... Let's see here. Models... You can actually go higher than 4. I guess that would be nice, but fuck, like it's a bit too unoptimized. Or what I'm worried about as well, let's see here. Bone weight actually only have 4 indices here, but I'm wondering about bone weight 1. Bone index and weight. Skinny weight for bone. Can you have... Up to 255 bones. Holy shit. Okay, so I guess let's just see what kind of result we get with this. If we do... Wow, that's actually pretty damn nice. Yeah, the legacy scripts written 2 days ago. It works with imported models, not procedurally generated. We're gonna have to look into that eventually. But then we can do test. Let's see here. We can actually do... Let's do... Serialize... let's do this. Holy shit, this is a little bit too crazy actually. But... So we have bones here. Instead of taking 4... Let's just take them all. And total weight should still be okay. And instead of doing this here, we do... bone weight 1, bone weight is equal to new bone weight. I wonder if we can add after the fact. So bone weight dot, actually maybe bone index weight. Yes, Gafer, we're gonna use that bone weight linearly, could try exponential fall off. Yeah, we could go a little bit crazy. First of all, we're just gonna manage, or first I just want to manage to set all of the bones. Like, I'm wondering how to create this one actually. What, do we have any constructors, or like bone index seems to just be an int? Weight is a float. Like this one, we have something like this. For bone weight 1, we just have... Index of bone. Okay, do you... Mesh bone weights returns bone weight. That's the wrong one. Get bones per vertex. Okay. Get all bone weights returns a native array with bone weight 1. Non-zero bone weights for the mesh in vertex index. Oh, do... Oh, so for vertex 0, if vertex 0 has 4 bones, is the first 4 slots for this one related to the first vertex? For each vertex, the bone weight 1 structures are sorted by bone weight 1 weight in descending order. So when we set the weights, bone weights here, we want to do mesh dot set bone weights, bones per vertex, native array byte. Oh, I get it, I get it, I get it, I get it. What? Okay, so we can have a varying amount of... Okay, this is pretty cool. Pretty fucking cool. So... I guess what we want to do then is bone weight, new. Okay, we want to do I'm wondering why. Okay, so we do this. Is equal to what do we need to thought it was that one. Okay, there we go. So we do weights, and then we do... So the number of weights here is... Fucking hell. It's gonna be... Am I understanding it correctly if we do... mesh vertices dot length multiplied by bones dot count, right? But yeah, we want to instantiate this one here. And then we also want to instantiate a new native array where we have the number of bones per vertex. But Can we create a native array with, so we have weights, and then we want native array byte. Yeah, bones per vertex is equal to mesh vertices length, but I also want to, would love if we could instantiate this one with a value. Fuck, is an allocator. Yeah, okay. Like if we could fill it up. But maybe we can do, instead of this, we do array dot thought it was something like that, but let's see. Because we want, so we want an array which just, where every element is bones count, pretty much. There we go. So bones per vertex, enumerable dot repeat byte bones dot count, and we want to repeat it for mesh vertices length, and then I guess it's, oops, to array. So then we have a native array of bytes. It's as long as vertices, and each element is bones.count. And then we have weights here, which is just mesh vertices length times bones count. Does that make sense? I think so, yes. So then when we fill it up, so this is per vertex. Then we want to do, oh, we also get this one by default. Like, let's see here. Where do I? The bone weights for each vertex must be sorted with the most significant weights first. Beautiful. We already have that in closest bones with weights, total weight. So what we want to do here then is weights I times bone count, right, is equal to new bone weight 1. Bone index is element at 0 index. I don't remember, do we care about index in this one? Maybe we do. And then weight, total weight, I think. Yeah, let's try this. And then when we set the bone weights, we set it by bones per vertex. And weights. So now instead of having 4 bones per vertex, we have like every bone is affecting every vertex pretty much. Okay. Let's see what kind of result we get. But I wonder how, like, this is extremely costly, I think. Okay, we get an error. Vertex 0 bone weights are not in descending order. Really? That's not good. When we divide by total weight here, we should have, so it's 1 divided by distance, divided by... So no... Oh, 1 sec. Yo, what's up there, Rabo? Long time no see. Love the recent videos you put out, man. Thank you, appreciate it. Hopefully we can get some long form videos out soon enough as well. How are you doing? How are you doing, man? Fuck, do we still get this error? The bigger this one is, the smaller this one is, right? So the greater the distance, the smaller the value. Why are we not getting them sorted? Oh, I fucked up here, didn't I? Yeah, what the hell are we doing here? Let's do 4 int j is equal to 0 bones count. That's what we want to do, right? So for each bone, add a bone weight 1, and we do it on I times bone count plus j, and these should be sorted. Okay, this should be correct, right? They're both doing great, currently 3 weeks off work, so it could not be better. Everyone happy and healthy. Okay, yeah, that sounds pretty damn good. I'm reporting the same, pretty much. Like I'm in a period of my life where I have like 0 complaints. Or I have 1 complaint, and it's this error. So, pretty damn good. Vertex 0 bone weights are not in descending order. How? In what way are they not in descending order? Oh, yeah. Like we order by distance. Descending. Yeah. We order them by distance, so smallest distance first, biggest distance last, and the weight should result in the biggest weight being first and the smallest weight last. So what are you doing these days, Derobo? Are you still like doing anything in Substance Painter or the like? Or is it just real life stuff? Do we fill it up the correct way here? Index, weight, total weight. I want to do something weird. I think we're gonna do... Yeah, let's do this. I is less than weights dot length. I plus plus. Okay, we have a lot of weights, so this might be stupid. We can minimize the weights a little bit. So let's do debug log. Bone weight. Where should it? Weights. I dot bone. Let's do it like this. And then we do, yeah, before we play here, we're gonna have to minimize this one, 6432. Let's do 16.8. Durable, I'm all over the place. I wish I had less interests. Still doing a lot of home improvements and some game dev on the side. Mostly just learning new stuff for me instead of actually putting something finished out there. It's about the journey, right? Yeah, that's what I tell myself every day. Durable, mostly running a ZBrush, Houdini, Substance, Unreal pipeline. Yeah, that's pretty much what you ran last time we spoke, I think. Have you experimented something with like generative AI? Look at this, we don't get an error here actually. Why don't we get an error? Interesting. We only have 2 bones as well. Look at this. Holy shit. That's beautiful. If we can get some... this is good. But we have some problems. Okay, so when we only have 2 bones, we don't have any problems. And oh, what is this? Is that not a number? Because that is one of our weights. That's not good at all. 0101. So... bone index. So the weight for this one is not a number, I suppose. And I guess we have the same issue at the end as well. Yeah, we do. But that's probably because that's why we get this issue. I thought the epsilon would fix it. Deborah, yeah, I love mostly procedural and node-based stuff. It just clicks with my brain and not. Not a big fan of generative AI, but it's getting crazily good. Yeah, I'm mostly like trying to get into the groove of using AI as my coding assistant, right? as for like generative stuff, when it comes to like textures and models and stuff like that, I haven't really tried anything. But like I'm itching a little bit to try it with textures. But I still, you know me, I still want to have like full control. But we'll see. I'm wondering why we get not a number for this one here, because that's what I'm guessing it is. That would be dividing by 0, but how the hell can we divide with 0 if we have math f epsilon? I wonder what... Is this one too small? Let's do 0.001f. Let's just try with that and see if we get an error still. Okay, we had a did we actually have a too small of an epsilon? That definitely seems to be the case. How does this one? Ah, now it looks great. And then we do... Fucking hell, look at this. We're gonna get some nice soft bodies on these, I think. I think we're gonna settle on, if we're doing every vertex is connected to every bone, we're probably gonna have to lower the number of bones eventually. Let's see if we get the same error now when we have fixed the not a number issue. And oops, I want to heighten. I want to heighten this one again, so we're gonna go 64. 32. Darabo, yes, for textures it must be amazing. Sketch something in Paint and get a good looking texture as output. Yeah, that's what I'm thinking. Thanks to NVIDIA DLSS 5, you don't even have to wait to embrace Gen AI. They will do it for you. It's both so incredibly interesting and depressing. Okay, no errors, that's good. Meme, that looks squishy. Yes, it does. Let's see how this looks now when we have... Like, we have 13 bones, so each vertex here has a weight for each 14 bones. For each bone. Let's see. Oh, do we actually get something like this? Okay, that's not what I anticipated. Okay, yes, I know what's happening here. Okay, so our bones are always positioned at some of our vertices, which means that these vertices will have a weight of 1 for that bone, which means that all of the other bones will have 0 effect on it. So that's definitely something we need to fix. Other than that, for all other vertices, it looks good. So this happens when... I love this. This was actually pretty easy to implement as well. But, so here, when the distance here is 0, we get... it's not entirely 1, is it? But we almost get a weight of 1. Let's see, do we get... So if we put... Let's do... We do drag them a little bit, do we? Not. think so. But yeah, it's definitely too big of a weight. We don't want this, right? So what can we do to avoid this? I guess the epsilon can become a little bit bigger. Yeah, I just want to try that real quick. Curve scapher, curve, maybe. Let's take an epsilon of 1. Or you know what? One sec. Yeah, let's just try it. We want to avoid... Like, we want to move all of the weights away from 1, but we want to move them away from 1 depending on how far away they are initially. But maybe this... let's see. Yeah, I think this is a pretty good compromise, I think. It's not perfect. But then again, you're always gonna have problems like this, right? So what if we take... Nah, we want to avoid this, I think. You know what? The lesser the bones, the better, probably. I want to see... Let's time 0.5. Oops. Time 0.5. Now we only have... Fuck. Okay, now we only have... Maybe 1 extra bone would be nice. But yeah, we definitely want to avoid... So now we have 1 here. This is probably... Okay, I think maybe this is a good... Oh wow, did I fuck up? Yes, I did. Never mind. Let's change this one times 0.5 and this one times 2. I think this is the... So we have 1 at the bottom, and then we have 4 on each side, and then we have 1 at the top. And we have something like this. We have something like this. But then we have this. But, I mean, I don't even know if we move this bone down here, like, how do we actually want it to look? I don't know. I mean, pretty fucking cool. I want to get this configured with some configurable joints as well. I think it's going to look good. Yeah, I'm still... Yeah, sharpness. Let's see here. Inverse distance to sharper fall off. I don't think sharper fall off is what I want this time around. I would like... Like, I'm wondering if... I'm wondering if you could do another cheap hack to just add some, like, or that might be a bit too much, but like add a big number to the, or not a big number, but add something to the sum such that no weight has 1. But then we can, yeah, and then we can probably put it into some kind of transform function. Yeah, we can. Eventually we can experiment a bit here, because what we want to avoid is, we definitely want to avoid these pointy effects like this. But I'm still wondering why. This definitely looks like a weight 1. Why do we still get a weight 1 here? Never mind. Total weight. Weight divided by total weight. Is 0.5. Yeah, 1 divided by, yeah, that's gonna be a lot. Bucket times 2.0. What am I misunderstanding here? But you know what? I'm wondering if wondering if I thought I read it somewhere. I'm a little bit scared that Unity normalizes the weights automatically. Get. Let's see if it understands this. But if that's the case, what can we do to get around it? Yeah, we want to give the other. Like we want to make the bones further away affect it more for some reason or in some way. But are we in a loop? Oh well. Local LLM web scraping. Yeah. But I wonder why, if we multiply this sum with 2, that means that no weight, like, then it's not going to be sum up to 1 ever, right? So I would definitely say that it's normalizing it after the fact. I want to see times 0.5. Turbo, back to lurk and doing some stuff over here. Really nice to catch you streaming. Are you currently streaming on a schedule? Thank you for dropping by, first of all, and thank you for the lurk. And right now I only stream on Mondays and Tuesdays. Unfortunately around like 3 hours each time. But hopefully we can add some hours to that schedule soon enough. Okay, look at this. If we do... So for each weight, let's just try and multiply with 0.1 here. If Unity doesn't normalize this shit after we add it, then we should have barely any effect on, or just 1/10 of the effect on the closest bone. There, I might catch 1 or 2 more streams if I get lucky. I appreciate it, man, and have a good day, you too. So what I'm seeing here is that we're definitely getting more. Like, this is not 0.1 weight, so we do normalize it, I guess. So the further away we are, the smaller we want to make this one. And can we do it by square root, maybe? Right? Or does that make any sense? But increasing the 0.001 will make all weights more constant. Yes. Oh, fuck, let's try that first. Didn't we do something similar? Distance 0.1. Let's go with 1.1. It does make sense, doesn't it? There we go. 1.1 is pretty aggressive, but I think I also want to make it a bit more rounded here. So pretty much what I want is we want to reduce this one the closer we are. Square root or fractional power will increase the size of the fall off. I wonder. Doing the power of will just make this one. Yeah, we're gonna have to do a square root. Do we have not square root then, I guess, but actually let's try square root like this. Holy shit, Skafer. Yeah, that's an old school emote. We're probably gonna add some blob emotes eventually. Is it? Did square root make it work? No, it didn't. But let's do... Okay, let's do something like this. I wonder if we can do... Let's do square root on all of this. And make this one maybe like this. But yeah, we're probably gonna go with... Yeah, we could probably use animation curves eventually. An animation curve for this would be beautiful. I think. Okay. Actually not too bad. But... Can we make this one depend on... Okay, I think we're gonna, instead of brute forcing this, we're like, if we sit down, we can probably come up with a pretty nice solution. I think I know how I want to handle it, but let's see. This is still way better, but what I think we're gonna do is... Let's see here. Oh, let's see here. But let's see, could also try x minus fall off times distance instead of 1 divided by distance plus 1. Okay, let's try it. Okay, oops. Yo, some sick tech. Okay, let's see, x math f dot x minus fall off. So that's a value we choose, alright, I guess. What value should we have for fall off? 0.1, or is that too small? Times BD distance. In fact, this flies over my head, but let's see. I was thinking... okay, let's see 0.5 and 2 soon. I just want to see what 0.1 gives. Bro, okay. Let's try... What if we go minus 1? Wow, that's like best yet, isn't it? Can we get even more of a curvature here? Magic of constants. Holy shit. Okay, this is like worst case. But fucking hell, that's pretty damn good. Appreciate it. It's pretty damn good. Although, let's see. I wonder how this would work with more bones later on. Try 4. Oh, that might be a bit too high, maybe. Wow, that's beautiful. Okay. Okay. Holy shit, it's like almost like an entirely different material. Okay. I reckon 2... I wonder if 2 is a little bit too big as well. I'm gonna see if we can make this into... or add it like adjustable from the editor. Because I guess we're gonna play around with this one a lot. But I think... yeah. Okay, I think this is definitely good enough for now. And then we will... although... maybe we want a bit more actually. Yeah, I think it's gonna look pretty damn good. Although, okay, I've messed it up quite a bit, but okay. Unfortunately, I won't have the time to put it all together with some configurable joints today because I need to run. But holy shit, this has been productive and fun. And I think it's gonna look amazing next week when we get all of the different building blocks in place together. Fucking hell. Yeah, thank you so much for watching, everybody. Appreciate it. Thanks for all the help as well. Yeah, have a great rest of the week and a beautiful weekend. Peace.